Okay, this is the packet tracer topology that's in the book. It's the one that's going to be in the book. Initially, he doesn't have this network in here, but it has to be there, so I just went ahead and added it before we started. I've already put the IP addresses on these things. Let me turn off. Clean this up a little bit. Let's not show the port labels. A little bit cleaner here. I think that I have anyway. Exit. Show IP interface. Brief. So yeah, we have the IP addresses around here already. So we have a bunch of 10 networks with 24-bit masks, kind of like the picture we saw in the lecture. 10, 10, 10, 10, 10, 11, 10, 10, 20, 10, 10, 30, 10, 10, 40, 10, 10, 50. So what we're going to do, and in the middle here we have the 172, so that makes it a discontiguous network. When we get to go in here, we're going to have a dual path to this network here, which doesn't have anything on it. Have to have switches in here because you have to actually plug in the Ethernet ports before they'll come up. You can't, it just won't work for me unless I do. So doing his thing, the first thing we're going to do is go to the corp router here that we're on, and let's see, we're enable, we're going to config T, and we're going to configure EIGRP. So it's router EIGRP, and we're going to use Autonomous System 20. And in this case, we're now, since we're using IPv4, we need to advertise our network. So the networks that we want to use here, I'm going to drag this down, are going to be the 172, which is on the serial interface, and these 10 networks. We could individually advertise these and use the wildcard mask 0.0.0.255, or we can just advertise everything. And doing this, we want to just advertise everything so that we can see what the auto summary does for us. So we're going to do net, if I can spell it right, 172.16.0.0. Class 4, that's a Class B network, and then network 10.0.0.0. And I'm honestly not sure that when you do the CCNA, they may make you use the wildcard mask when you do these things. So the next thing we're going to do is go. He's got in here how to do it with the wildcard mask. We could do it with the wildcard mask. Seems kind of redundant to do it that way since we could do the 10 network, 10.10, 10.0, 10.10, 11.0 with the wildcard mask 0.0.0.255. So we would advertise them individually. When we do the network here, I'm going to try this, zoom out. When we do the network here, what we've done, you can't point at it when it gets here. The network 10.0.0.0 automatically advertises every network that starts at 10 that's on that router. So we're going to go to the other routers. Let's go to San Francisco here and enable big T, and this is router EIGRP, and we use 20, right? Network 172.16.0.0. And when we do that, you notice that it says that we have a neighbor formed already. So EIGRP really does form pretty fast. So we dual exchange EIGRP 20 neighbor 172.16.10. Now we need to go down here and also do network 10.0.0.0 because we have 10 networks on all of these guys. And then let's go to the New York router and router EIGRP 20 network 172.16.0.0, right? Got that adjacent, so that's a good sign, so they're talking to each other. And then we'll do network. I just do, I could have typed up there, I just like to be able to see the whole thing. Network 10.0.0.0. Okay, so we talk about the tables, and he's got other ways to do these things. So let's go to, I'm just going to try to go through it the same way that he's got it in the book. And we're going to go to the corp router here. Now, that's the problem with this thing. Oh, I can get out. I can't use Control Z because that's what I did with the zoom. So, show IP route. And when we do this, up here at the top, maybe the zoom will work better here, we have 10.8 variably subnetted, but when we go down here, we keep going, these are the ones that are connected, directly connected to it. So we have these things. And we have local, we have these. So auto summary is turned off on this thing. I thought I had turned it back on, but I didn't. So this one is working, and this is the one I said by default it should be off. So let's just go in here and turn it off and see what it does. Just so that you see, and this would be what would happen to you on a router. Router EIGRP 20, right? Auto summary. And let's put it on all of these routers. See, it told me you haven't got a graceful restart. Router EIGRP 20. Auto summary. San Francisco, and let's go to New York and do the same thing. So router EIGRP 20, and then I'm going to have to go back and take it off. Auto summary. So it shouldn't make any difference which one we go to. They all should sync that. Now that one won't work, will it? Variably subnetted. You notice that we only have variably subnetted null 0. It says it's a summary. And each of them is going to say it's a summary because each of them with the auto summary think they own all of the 10 networks because of the way that we advertised it. We could have advertised it with the wildcard mask, and it would be a little bit different. The 172.16s are fine down here. We have well, actually it's got a summary too, doesn't it? Well, yeah, it does. Both of them have a summary. So the summary summarizes all of them, and if we go to one of these others, let's do show IP route. So I don't have to have as many. Do show IP route, and again we still have the summary. So configure router, I should still be in that thing, right? No. Auto summary, and we'll have to do that on each of these again. And if we had tried to ping one of these things, it wouldn't have worked. And this one, since I was cleverly got out of it, And now we have the D's, the D for dual. These are going to be, the D's here are going to be the EIGRP routes. D for dual, which is the algorithm that it uses when we do these things. Okay, so it does VLSIM, and that hopefully the auto summary and the no auto summary kind of makes a little bit of sense. The passive interface, we could turn on the passive interface, and we could give the neighbor command. He does those things, and he does a maximum hop count when we do those things. I'm going to turn my zoom off because I think it's slowing me down. We had a bunch of tables, right? This is the route table. Show, is it IP, GRP, topology. When we look at this thing, connected successors, each of them has one successor because I haven't advertised the other route. I'm going to go ahead in here. I think it's a 192. I think that this is a 192.168. Just so that we can see successors 192.168.10. So we can go back to config T router EIGRP 20, right? Network 192.168.10.0. And then we go down here to New York and do the same thing. This way we're going to create some dual routes and see what happens. Guess it really wasn't my zoom. Right? New adjacency. Okay, see, and now we have an adjacency. Let's look at some of these guys. Since they're connected to that switch, show IP neighbors. So this guy has two neighbors, and then this number over here is just the order that they form the adjacency in. So out of serial 001, which was the first one, we have an adjacency in gig 02 to 192, and it tells us the address of these guys. And show IP GRP topology. We have one successor, but down here via to get to the 172.16.10, we have two different paths to get here. So we've got the successor, and then we've got a feasible successor in here. The P over here is passive, and that's what you want to see in the topology table. It means it's figured everything out. If it gets an A active, it's still trying to make it work. And then we have all the abbreviations up here, the update, and those things. But mostly we have one successor for each of these things. Let's go back to Corp here for a minute. Let's see if we get in here. I want to show the IP route first. So we have a bunch of these things that we go in here with, and when I get to my 192.168, I have two paths. We can go either via 172.16.10.2 or 10.6, and they're the same cost. So it automatically balances with equal costs on these things. If I go in here and change maybe the bandwidth of one of these, then one of those will go away. let's go ahead and see if we can let's see if I can make myself a liar. Big T interface 0/0/1 bandwidth, let's say 512, because bandwidth and delay is what we said that it works, right? So now then we've reformed the adjacency. Now watch it make me a liar. No, we only have one route to the 192.168 because the metrics, the bandwidth and delay are different. I think the default bandwidth on this is 1500 or something like that. We can say back to the default in a second. But if we show the topology table, when we get to the more here, 192.168 have one successor. The feasible distance is 217. .416, but we have another route down here, but it is going to cost more. The advertised distance here is both the same for both of them, but when we get to the advertised distance is what it costs these routers to get here, which is a gigabit, so that's what the gigabit cost is. But when we add the cost across the serial interfaces, they are different, which then gives us the single route, whereas before we had the other one. And let's just go one step further here. We talked about variance, and we'll do it again here in a minute. Let's see, config T, and then interface 0/0/0/1 I used, right? Maybe I'll VARI variance is not here. You know why? Because that was an EIGRP configuration, wasn't it? Variance, and let's say 2. So we go through that whole mess again. And the reason that I want to do that, Control Z, show IP route. Yeah. Well, we still didn't get the other one, did we? Maybe the variance wasn't big enough. Anyhow, when we do the variance, we should have gotten. I'll pause. Okay, back to looking at the topology table. The 212 and the 551, a variance of 2 may not be enough. So let's try a variance of, let's make it really big. Let's go 4. The router EIGRP 20, variance of 4. Yeah, hopefully this works. Yeah. Now we got a bunch of stuff going on around, huh? Now, okay, there then. See, the variance wasn't enough. What we have here are 2 routes that are going there. A proportional amount of traffic will go on each of those. And notice that the administrative distance of EIGRP is 90, and I think that's the lowest of any of them that we've had so far in it. Which means except for static routes are directly connected, if we have multiple protocols running on the system, then it would use the EIGRP instead of OSPF or instead of RIP. So we did a little bandwidth trick there. So and we did the variance, and so we can do that. Hopefully, and that I wanted you to see that. Yeah, you can have. By default, it will do up to 4 equal cost paths. You can make it do unequal cost paths by using the variance command in the system. see what other things that he did here. We could show interface 00/0/1, and when we look at it, this is the one that we changed the bandwidth on. So here its bandwidth is 512. Its delay is 20,000 seconds. If we go to, let's just go to the other, show interface, I feel like I could probably do this, 0/0/0. If we do it, its bandwidth is 1544, and that's why I talk about we really need these things to be the same before it's going to do a balanced. The bandwidth and the delay have to be the same. The delay is the same, 20,000 microseconds, and this is in tens of, when you configure it's like in tens of milliseconds or something like that. Tens of milliseconds. It's kind of a strange configuration. So I think looking at that we looked at the topology table. We did an unequal balancing. Split horizon we talked about. The only thing that you do there is split horizon is, let's see if we do show IP interface 0/0/0. Should tell us that not everything, as we found out, gets converted when we do the packet trace or do the simulator. Serial 00 is app hardware encapsulation list input queuing, and it should tell us that we don't have an access control list, and it doesn't say that. If we have one, it should say that it's there, and this is one of the places you can find out if you have one. While we're here with the default encapsulation, this is for like next Tuesday. HDLC, and that's the default for Cisco, and all HDLCs are proprietary. So if you connected a Cisco to somebody else and they both had the HDLC, you got to go to like PPP. You have to do a common. This is the layer 2 encapsulation protocol for the serial link. So we did that. We talked about split horizon. So I think that is the configuration demo. We've got one more. I've tried to set up his troubleshooting demo so that we can go through it. We're going to start out not working, and we're hopefully going to get to the point that we are working.